Hey guys, in this lesson we would understand the applications of vector and parametric equations. We would be covering up 5 different types of questions that can be asked from vector and parametric equations. Let's take type 1 question first. So the first type of question is, you were given a vector equation r equal to -1, 5 plus t, 7, 6. You are asked to determine point r, which is equal to x, y. And x and y are the coordinates of that point. First, let's understand the question. We are given a vector equation of a line. So this is the axis. Let's say the line that we're looking for is this. And we are given the line equation as this. So r equal to -1, 5 plus t, 7, 6 is the vector equation for the line. Now, if we have to determine point r, this r point is any point on this line, could be any point. So when it is any point, that means there could be infinite answers to this question. So how do we find out this r point, and which specific point are we looking for? It's no specific point, we are just looking for any point. So everybody's answer could vary depending upon what you take and how do you take and what you take. We're going to discuss here in steps. So first, we are always going to change the vector equation to parametric form. Parametric form is x equal to -1 plus 7t. We would notice that most of the questions will be solved using parametric form. And we are given y equal to 5 plus 6t. Once we get the parametric form x and parametric form y equation, we just have to substitute t for a number. In the previous lesson, I told you t represents a constant. So this is the time where we have to put in the value of the constant. And t that we are putting is going to be same in both x and y. So let's consider t is 3. We can put anything. You can put -1, +1, 4, 5, 6, whatever. So x would be equal to -1 plus 7 times 3. That gives us -1 plus 21, which is equal to 20. Similarly, we can solve for y value. Y is 5 plus 6t, so t is 3. We have 5 plus 18, that is equal to 23. So we got xy as 20, 23. And this is the r point. This r point, 20, 23, means the x is 20, y is 23, should lie on this line that is defined by the equation. Answers may vary for this type of question. Now, this is another type of the question, type 2. This question wants you to determine if point 65 lies on the line that is described by this equation. So this is a type where you can be given a point and you could be asked to determine if the given point lies on the line or not. So if we understand it with the diagram, let's say we're given the line. This is our line represented by equation r equal to -1, 5 plus t, 7, 6. And we have to determine if point 65 lies on it. So let's say 6 is here, 5 is here. We need to find out if 0.65 lies on the line or if it's outside the line. Now, in order to do that, we again have to write this equation in parametric form, for which x is equal to -1 plus 7t and y is equal to 5 plus 6t. Once we write it in parametric form, we have to isolate t. And what x and y value are we going to use is, x is 6, y is 5. So x is 6 minus 1 plus 7t. We need to solve for t, so we'll isolate t. 7t stays here. -1 goes on the other side, becomes 6 plus 1, which is 7 divided by 7 equal to t. So t is equal to 1 in this case. Similarly, we'll solve for t from y equation. So we have y equal to 5 plus 6t. Y value that we're going to be putting is 5 because we're looking for 0.65. X was this, y is this. And then we would be isolating t again. 5 minus 5 is 6t. This is 0 equal to 60. So t is equal to 0. Now, since t is equal to 1 and t is equal to 0 here, we have different t values. For a point to lie on a particular line, we need to have the same t values because t has to be constant for that particular line equation for a point. Since we're not getting similar t values, that means 6, 5 does not lie on the line. And this is how we do type 2 problem, where we have to determine if a point lies on the line described by the equation. We just have to solve for t values, and we can do that when we change the equation to parametric form. Similar t-values means the point lies on the line. Different t-value means the point does not lie on the line. Another type of question wants us to find the point of intersection of the line given as R with x-axis. Let's draw a diagram for this. We're given the line described by the equation r equal to -1,5 plus t 7,6. We have to find out point of intersection of this line and the x-axis. We know this is the x-axis, so point of intersection of the line and the x-axis is going to be right here. And let's mark this point as A0. Why are we writing y value as 0? Because it's on the x-axis, so we know y value on the x-axis is going to be 0. And this point, x point, let's consider it as A. So from here, we know that the point of intersection that we are looking for is A0. We already know the y value of the coordinate is 0. But we are looking to find out the x value of the coordinate. Again, we would work with parametric form of equation. So we're going to write down x and y separately. We have x equal to -1 plus 7t. We're looking to find out A0 coordinates of the point where A belongs to the x value. So we'll put in x as A, -1 plus 7t, and the other parametric equation represented is by y. So y is equal to 5 plus 6t. Y value we definitely know is a 0. 5 plus 6t. We know for a point to lie on a line, and we also know that this point would lie on our given line. We need to have the same t values. So let's find out the t value from this y equation and substitute that t value here to get the x value. We'll isolate t, so we'll move 5 on the other side. We get -5 equal to 6t. So t is equal to -5 over 6. Now we would substitute this t value here because t is supposed to stay same. So a is equal to -1 plus 7. In place of t, we would put -5 over 6. When we solve this, we would get -1 minus 35 over 6. After making the denominators common, we would be able to get -41 over 6. Therefore, this a coordinate will be -41 over 6 and y coordinate is 0. So the point of intersection is -41 over 6, 0. And this is how you find out the point of intersection with the x-axis. If they had asked us to find a point of intersection with y-axis, then we were looking for this point. And in that particular case, you would put 0, b. So you would have been using x as 0, solve for t, and substituting t in place of y equation to solve for the y coordinate. And this is how we find out the point of intersection whenever a line is given in the form of equation, that is the vector form, with the x or y axis. Next type of question, type 4, asks us to determine if this equation r equal to -15,9 plus t 14 over 3, 4 also represents another form of this equation. In order to do this type of question, these are the steps that you would follow. Step 1, and that is to find if the direction vector of the question equation is this equation, is a multiple of the given equation. So the question equation direction vector is this. We would write down m direction vector is 14 over 3, 4, and we have to figure out if this direction vector is a multiple of this direction vector. Multiple means that anything multiplied by this would be able to give us this or not. And we would be able to figure out that when 1.5 is multiplied by 7, 6, we would be able to get 14 over 3, 4. 1.5 multiplied by 7 would give 14 over 3, and 1.7 multiplied by 6 would give us 4. So this question equation direction vector is a multiple of the given equation. So our first step is cleared. If the first step is clear, then only we would move to the second step. If let's say this was not a multiple, then we would not have proceeded to step number 2. Second step is to find if the r0 point of the question lies on the given equation. Let's go back to the question equation. r0 of the question equation is -15,9, and the given equation is r equal to -1,5 plus t 7,6. We have to find if this r0 point lies in this equation. So if we have to figure out if this r0 point lies in the equation, that means we have to find out whether this r naught be equal to r of the equation. For that, we have to write this equation in parametric form. So the x value is -1 plus 70 and y value is 5 plus 60. We substitute x as -15 and we solve for t. This would give us t equal to -2. Now we substitute y as 9. Isolate t. 9 minus 5 is 4 divided by 6 is t. So t is equal to 2 over 3. And we found out that the t values are not same. If t values are same, only then the given point lies in the equation line. If they're not same, then the given point does not lie in the line equation. So step number 2 has failed for this particular question. If both step 1 and step 2 passes, then we would conclude that the equation represents another form of the given equation. But in this particular case, we would just conclude that this equation does not represent another form of the given equation. Let's quickly summarize the question. The question wants us to determine if this equation, -15(9) plus t 14 over 3, 4, also represents another form of this given equation. Step 1 is to find out if m of this question equation is a multiple of the given equation. Question equation is 14 over 3, 4 direction vector. And the given equation direction vector is 7, 6. We figured out that when we multiply 1.5 with this equation, we are able to get this. So step 1 is cleared. Step 2 is we have to find out if this point lies on this equation. For that, we have to write down the given equation in parametric form and substitute x and y for r value and solve for t. Constant t value, we would conclude yes, this is another form of this equation. If the t values are not constant, we would conclude this is not the other form of this equation. Next type is the last type of the question. Determine the vector equation for the line that is perpendicular to this line, where s belongs to any real number and passes through this point. So we have to find out the vector equation for a line that is perpendicular to this line represented by the equation. Let's understand this with a diagram. So we are given this vector equation. Let's say this is the vector equation of the line, or let's say this is line R. We need to find out another line that is perpendicular to this line passing through point 6,5. So let's say 6 is here, 5 is here, and this is the point. We have to find out what is the line equation for the line passing through this point 6,5 and is perpendicular to the given equation. The given equation for the line is r equal to 4, 1 plus s -3, 2. So we are finding the equation for this line. Now we already know from the previous unit that two lines, when they are perpendicular, their dot product is 0. Here we are going to find out the dot product between the direction vectors of these two lines. This is the direction vector for this line. To find out the direction vector for this line, we have to assume the variables. So let's say we are writing the equation of this line, and let's call this line as a blue line represented with r equal to r naught plus the direction vector. Here we can represent it with any other alphabet because this is just a constant, and let's write on the direction vector AB. Because the two lines are perpendicular, we definitely know that this and this dot product is going to be 0. So dot product of 3, 2 and AB is going to be equal to 0 as the lines are perpendicular. We already know how to find out the dot product. We just have to multiply x with x and y with y and add them. So -3 times a is -3a plus 2b is equal to 0. Now for finding the value of a and b, we can pick any numbers of our choice that would give us the left side equal to 0, so that the left and the right sides are equal. If we put a as 2 and b as 3, we would be able to get -6 plus 6, and that gives us a 0. So this is the smallest possible value of AB, 2 and 3, that would give us the dot product of both of these direction vectors 0. Therefore, we can conclude that point AB is 2, 3 here. Let's call the direction vector of the line that we are finding the equation for n. So it is 2, 3, and the direction vector for the given line equation is, we already know, is -3, 2. Here we note down something, that for a given line, the perpendicular line's direction vector is negative reciprocal. We know direction vector is change in x, change in y. So change in x, change in y. Whereas the direction vector of the perpendicular is going to be change in y, change in x. And you have to negatively reciprocate it. So you can make either of these two negative. The first one was negative, it becomes positive. So basically this can be written as m was 2 over negative 3, n will be 3 over 2. So negative reciprocal will become the perpendicular's direction vector. Now let's write on the equation of the perpendicular. We know a point that lies on the perpendicular is 6, 5, and we know its direction vector. So equation R would be equal to 6, 5, because we are supposed to take any point that lies on the line that we're writing the equation for. T, direction vector is 2, 3, and this is the answer that we would get. Finally, as a equation of the line that is perpendicular to the given line.